the area under a curve. The task of finding areas under curves has been important to mathematicians almost since mathematics began. Before the advent of integral calculus, which can find exact areas, many approximate techniques were used. These are still important today, as not every function can be integrated. The approximate technique we will use here employs upper and lower rectangles. Suppose we want to find the following area. So the curve here is y equals x squared, and we're interested in the area trapped between the curve, the x-axis, which is the line y equals 0, the lines x equals 1 and x equals 4. We could approximate the area using the following set of rectangles. So let's look at the x-coordinates involved. So we've got 1, and since y is equal to x squared, the y-coordinate when x is 1 would also be 1. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9, so that's the height of this rectangle here. If we think about 4 as well, the height of the curve there is 16. But clearly we're not using a rectangle with a height of 16 in this original diagram. The area of these three rectangles would be 1 times 1, note each of them has a width of 1, so 1 times 1 for this one, then 1 times 4 for this one, 1 times 9 for that one, giving us 14 square units. Note that this would be an underestimate of the true area, as there's area under the curve that's not counted. For example, this bit here and this bit here, and there's also another bit there. Alternatively, we could approximate the area using the following set of rectangles, and here we have rectangles that fit over the curve. So we can see the height of this one is 4, and the height of this one is 9, the height of this one is 16. So using the same values here, but this time it's the rectangle of height 1 that we're not going to use. So the area of the three rectangles is 1 times 4, and 1 times 9, 1 times 16. Add those together and we get 29 square units. Note that this would be an overestimate of the true area, as there's area under the rectangles that's above the curve, so just here and here and here. We can improve the area estimate in different ways. We could average the estimates that we have, for example. So we could use 14 plus 29 divided by 2 and use 21.5 square units as an improved estimate. The best way to improve the estimate is to increase the number of rectangles. By doing this, the amount of area not counted or overcounted is reduced. The downside is that it takes considerably more work to calculate the area of more rectangles. So, for example, here we can see that we have all these little bits of area that are not counted, but in total they're going to be smaller than when we had just 3 rectangles.